Today we'll be working on section 6.4, but solving the absolute value inequalities. Now with the inequalities, you'll actually solve them the exact same way that you did before, but as you do them, you'll want to make sure you glance at those inequalities. Now, when the inequality is less than or equal to, you're going to be using, it's going to be an and inequality. And so the graph should look like it comes together there. And when you have greater than or equal to, it should be an or inequality. So on the graph there, the graph should go separate, it should go apart. So that'll be a nice way of checking our answers to see if we're doing them right. And so the way I remember that is less than or equal to should be an and, so less and greater than or equal to, I think of greater. And so greater than or greater than or equal to would be an or problem. And so going through here, even though this is different than before, the method for solving is exactly the same. We want to get that absolute value all by itself. So I'm going to add 3 to both sides. So now I had the absolute value of 2x plus 1 is greater than or equal to 9. Now this is the part that gets tricky here. The first part's no problem. 2x plus 1 greater than or equal to 9. No big deal. The second part, then, we have to remember, since it's the absolute value, we want to look at 2x plus 1 could also be negative 9. Now the tricky part is I went from a positive 9 to a negative 9, just like we do when we multiply or divide by a negative number. When I go to the negative there, I got to switch that inequality around because I'm looking at it being the opposite there. And so when I solve this, I just go through and solve it just like I did with equations. So 2x is greater than or equal to 8. X is greater than or equal to 4. When I solve this, I subtract 1, 2x is less than or equal to negative 10, divide by 2, divide by 2. Notice I'm dividing by a positive number, so I leave the inequality as less than or equal to. Negative 10 divided by a positive 2 is negative 5. Now as I graph this, look at my two key points. I got this point over here, that's at 4. I got this over here, that's at negative 5. I always like to put a number that's in the middle somewhere, just to kind of give an idea of where the number line is. Notice that this is greater than or equal to, this is less than or equal to, so both circles are going to be filled in. And then I know the solutions are greater than or equal to 4. So I need this arrow going to the right. I know that these solutions are less than or equal to negative 5. So I need this arrow going to the left. Notice that they're going apart from each other. When they're going apart from each other, that's an or problem. So I go up to the original problem. It was greater than or equal to. Since it was greater than or equal to, I knew I should have been expecting them to go separate like that. So that's a nice way to check your answer to see if you got them correct. For the second example, again, I encourage you try to do this on your own first. So go through, try to do it on your own, try to graph it, and see if you can get the same answer that I'm going to get in a moment. Remember that equations and inequalities are a lot alike, and there's nothing really that much more difficult about inequalities. It's a little bit different, but not much. Similar to bacon and sausage. Bacon is amazing. That's like your equation there. That's awesome. Easy to work with. You fry it up, you eat it. It's amazing. Similar to bacon is sausage. Sausage is also incredible. So hopefully you've had time now to at least start looking at it. Feel free to pause this and go through and work that problem out. But let's go ahead. Let's work this problem out and see what we get here. So we add 2 because we always want to get that absolute value by itself first. So never forget, you always got to get that absolute value, by itself first. And so I do that, and I get that the absolute value of 2x plus 5 is less than or equal to 9. So that means that 2x plus 5 could be less than or equal to 9, and 2x plus 5 is greater than or equal to negative 9. Now remember, it's an and problem because we started with less than or equal to. And then when we go to switching this to a negative, when I switch from a positive to a negative, I have to also make sure that I flip the inequality around. And so make sure you flip both of those as you do that. Now as far as solving it goes, subtract 5, 2x is less than or equal to 4, divide by 2, x is less than or equal to 2. Over here I subtract 5, 2x is greater than or equal to negative 14, divide by 2, I'm just dividing by a positive 2, so it stays as greater than or equal to negative 7. And now it's still an end problem. Remember when I graph this end problem here, I'm looking at my two focus points there. They're at 2 and -7. I always like to put one that's kind of in the middle there, just to get that idea. Now, they're both going to be solid circles, because they could be equal to that. And its x is less than or equal to 2, so the solutions are this way. And its x is greater than or equal to -7, so the solutions this way. So they come together here. This whole middle part is my solution set here. Remember, I should have been expecting that, because all n problems come together in the middle like this. I knew it was going to be an n problem because the absolute value with the x in it was less than or equal to. Whenever it's less than or equal to or less than, I know it's going to be an n problem there. And so remember, that's a great way of checking your answers there. So hopefully you're feeling confident with inequalities now. Just kind of a thought to end you with. This is just, sometimes at night when I'm thinking about school and I'm lying in my bed at night looking up at the stars, I think to myself, man, I really need to fix my roof. Have a good night.